Welcome to Fun with Science, Engineering, and Technology. My name is Mr. Ross. This morning we're going to be talking about a couple of skills that engineers and scientists use. One is observation and the other one is inferences. My assistants this morning are Julio and Jason. All right. These are two skills that scientists and engineers have developed, and everybody uses them. Everybody makes observations. Everybody makes inferences, right? What is an observation, Julio?
The act of obtaining direct evidence through the use of senses.
Right? The act of obtaining direct evidence or evidence through the use of senses. What kind of senses do you think they're going to use?
The sense of hearing.
Hearing.
Smelling, tasting,
seeing, touching, right? Touching or feeling, right? All of our senses. What if we had something that occurred like last week, right? NASA made an announcement that they had evidence that a black hole, you know what a black hole is? Right, that's a real dense object out in outer space, right? It's very, very dense, has a lot of gravity. That one of those black holes gobbled up a sun in the galaxy. It actually sucked the sun in, tore it all apart. Right now, this is like hundreds of light years away. They couldn't see it, right? You couldn't look out there and say, "Whoa, there's a black hole gobbling up a star." So what they did, though, is their senses, they were watching, they have a special telescope that monitors X-rays, right? And this telescope looked out into outer space, and it saw a lot more X-rays than what it normally does. Now, you can't see X-rays, can you? You can see visible light, right, but you can't see X-rays, right? Those things where you go into the hospital and they take a picture of your insides, right, all your bones and so forth, right? You can't see those. But there is a machine that can take a look at it, and in fact, they actually have telescopes that use those X-rays to look at the X-rays. They don't look at the visible light, right? And what they saw was an increase in the amount of X-ray radiation from this particular galaxy way off in the distance, right? And then they come up with an inference. The reason those X-rays were generated was because this black hole, one of the suns in the galaxy got too close to the black hole. That black hole's gravity sucked it in and tore it apart, and when it did that, the star released a whole lot of energy, and part of that energy was X-rays. So they had an observation through their telescope. They were looking at the increase of X-rays, and they come up with the next step, which was an inference, some explanation for that, right? Which was an increase in the amount of X-rays being radiated from that part of outer space. And that gets us on to the inference, right? Jason, what is an inference?
An attempt to explain or to make sense of observations.
All right, it's an attempt to explain or make sense of observation. Okay? And this is the inferences that you make, or the guesses or explanations that you come up with, are based on what you already know. Right? If you were a caveman back a million or years ago and had no idea at all about electricity, we put you in the room here where it was dark, and you watch me, and I walk over to the light switch and turn the light switch on. The lights come on, right? Push the switch down, the lights go out. What would a caveman think? He doesn't know anything about electricity, never heard of it. What would he think?
That is magic.
He'd think it was a magic, all right? He'd think I was really something else, because I could reach up there and touch the wall in the cave, turn the lights on, right? Touch it again and turn them off, right? Make the sun come on, make the sun go out. I had to be magic, right? And what would he think about me?
That you're some sort of god.
You think I was some sort of a god, right? You guys don't think that, do you? No. So, but nowadays, if you see me turn the light switch on, you know what I've done is I've completed the circuit, and the electricity is heating up the filaments in the lights, and we get light. Turn the switch off, I break the circuit, no electricity coming to the light, and no light. So, what we're going to do next then is we're going to look for some footprints. Right? And we're going to make some observations first of all. What can you tell me about those footprints? They're footprints in the sand, by the way.
One is smaller, one is bigger.
One is smaller, one is bigger.
Different shapes.
They're different shapes. Okay. Are they both going in the same direction?
No.
You don't.
One is going this way, one is going that way.
How do you know that?
because it shows that the foot is going that way.
What if I was some sort of a weird animal that my toes went the opposite direction?
All right.
All right. Do you know of any animals that way? No. Okay. So that's a pretty good inference that you just made, right? Right. Your observations are one is big, one is small, right? They're going in opposite directions, which is really an inference, right? It's a guess, right? Because you did that based on what knowledge you have. But most animals, their toes, which are these little things here, are sticking in the forward direction. We have very few animals with toes going off in the opposite direction. So you think this one's going which way?
Up.
Up, and this one's going which way, Jason?
Down.
Down. All right. And one is bigger than the other. All right, so we'll go down here and let's take a look at these statements we have. One set of footprints is bigger than the other. Is that an observation or an inference?
Observation.
It's an observation, right? How do you know that it's an observation?
Because you looked at it.
Because you look at it and you can see it, right? Right. The next one, two different animals made the footprints. Jason, what do you think about that one? Is that an observation or an inference?
Observation.
You think it's an observation? Did you see the animals make the footprints?
No.
No. All right. So that's really an inference, right? Because they're different shapes and so forth. But, right, because we know that, you know, different animals have different footprints and they have different sizes, so that we say to ourselves, okay, those two different animals. But what if I were to walk along in the sand? I leave my big old footprints here like this, boom, boom. And then all of a sudden, because I'm very athletic and acrobatic, down, put my hands on the ground, stick my feet in the air, and I walk on my hands. And you come along later on, right, being some outer space guy, right, and you look and you say, okay, there's some footprints, right, and he's got 5 toes and they're big old fat footprints, all right, the toes are little short things, and then all of a sudden, boom, I got big old footprints now because I'm standing on my hands, right, and the toes are longer, so what would you say about that? It's made by two different animals?
No. Yeah, I would say that.
You would say that, right? But in reality, it could have been the same animal, right? Your inferences aren't always correct, right? But they're not wrong either. And it's a pretty good guess that, all right, this is made by two different animals, right? It's a pretty good inference because this one, the toes are pointing this way and it's going that direction, right? And these ones, the toes are pointing in this direction, and so it looks like they're going in opposite directions. Now, I'd have to really, you know, if I wanted my toes to go, my fingers to go in opposite directions, I'd have to really, you know, do a lot of twisting around to make it go differently, right? Two animals had a fight. What is that? Is that an inference or an observation, Jason?
I think it's an inference.
That's an inference, right? Do we know for sure that
No.
those two animals had a fight? Right, they could have been just walking up to one another and shaking hands. Right? They couldn't necessarily have a fight. Two footprints were made at the same time. Julio, what do you think about that one? Is that an inference or an observation?
Inference.
It's an inference. Do you think they could be made at the same time?
Could be.
Do you think they could be made at different times?
If they were made at different times, then the one on the top or the one on the bottom will overlap each other.
You think so?
Yeah.
Right. That's a very good inference, very good explanation. But what if would happen if you say that which did you say they're made at different times?
They could be.
They could be, right?
But they're not because they don't overlap each other.
They don't, but they're not because they don't overlap each other. All right. So you're saying because these footprints don't go down here and overlap these, and these don't go over here and overlap those, that they weren't made at different times. What happened to the animals? These footprints come down here and just stop. These come up here and stop. What happened to them?
He died.
They died? We haven't found any bodies. all right? But that's a good inference, right?
Yeah,
We don't see any signs of any bodies there. Anything else could have happened?
They could have just made those footprints
And then did what?
and stopped and left them there and then just took the things out. And the people that made them could have bounced. They could have left.
How did they go? How did they go away?
They could have just left walking.
But I don't see any footprints going off in any different.
No, not them.
Hmm?
People, they could have made those footprints by using sticks and things and leaves, and they could have just put them on the floor like that, and they could have just left them there. Left the
Okay, so
footprint there.
you think maybe these aren't really animal footprints, that maybe
They could be animal footprints, or they could be just that people made them.
or somebody made them, right? All right, what we're doing is what scientists and engineers do. I come up with an inference, you come up with an inference, we sit and discuss it and decide which one is the best one, right? We weren't there, so we don't really know what happened, right? But we have all these inferences, and we can make our best guess based on the knowledge that we have. But what would happen if, let's say for instance, in this sand, there was a little line running down through here like this, right? Just a little faint line in the sand, like you find on the beach, right? When the tide comes in and goes back out, right? They have a little line, right? So let's take for a moment that in the morning, this big old animal, whatever it was, right, was walking down here and going to the beach. He went in the water and swam away. Right? He would have footprints all the way down here. Okay? Then the tide come in. The wave washed up here and washed that set of footprints away. Right? Then this bird, the seabird, right, was out there floating around the water. He come up after the tide went back up. And he got out of the water and walked up here to that spot. Made the footprints. The others have washed away. And then he flew away. Would I get this picture? I would, right? Is that a good inference?
Yeah.
That's a good story, right? That's a good explanation. Maybe. I mean, but it could be wrong. I could be just as wrong as any of the others, right? Or it could be right. And what we would have to do if we were a bunch of scientists sitting around and these were ancient footprints and trying to figure out what happened, we would just have to sort of agree, right? We'd all come up with our inferences and our observations, right? And then agree on what would happen. So this first one set of footprints, bigger than the other, that is obviously a observation. All the others are what?
Inferences.
All the others are inferences. What comes first?
Observation.
Observation. You have to have an observation before you can have an inference. All right, we have another one. Let's take a look at it. Okay. What's that?
Rattlesnake.
It's a rattlesnake, right? Is that an observation or an inference?
Observation.
It's an observation, you sure?
Yeah, because you can see it.
I can see it, right? I can see that there's a snake.
With a rattle at the end.
Oh, you think there's a rat? You think that's a rattle up there? Right. Okay, it's an observation. It's a snake, right? And it has a rattle on its tail. Right? We don't know. We don't know for sure. That's what we can see, right? And down here, so our first one is an observation. The snake has a rattle on its tail. Okay. The next one is the snake will strike. Is that an observation or an inference?
Inference.
It's an inference. Okay. What about the next one? It's a rattlesnake. Is that an observation or an inference?
Observation.
You sure it's an observation?
Yeah. And it could be an inference.
Why? What do you think it could be an inference, observation and an inference?
Because you can see it. You can see and you could guess that if it's a rattlesnake. And you could guess that it's a rattlesnake, so it could be an inference too. You see?
Yeah, all right. It's really an inference, all right, because I look up here and I look at this thing, and my observation is, all right, I have a snake right here, and it has little things on the tail up here that I think are rattles. They could be something else, but I think they're rattles. Right? And so then it could be a rattlesnake. But if I were a real snake expert, right, my inference that it's a rattlesnake, right, maybe I could come up with another inference. Maybe it's not a rattlesnake. Maybe there's another kind of snake that has a funny shaped tail like that. Right? So that's an inference. The snake is mad.
You don't know that.
I don't know that for sure, right? But, Jason, is it an observation or an inference?
Inference.
It's an inference, right? We don't know whether the snake is mad or not, right? There's nothing up there that says he's mad. He may be very happy. In fact, he may be looking up at me, right? And I'm standing over top of him with a big stick, right? Getting ready to clobber him in the head, right? And he could be afraid. He could be fearful, right? And if he's afraid, will he necessarily strike? Or will it maybe turn around and run away?
It'll strike.
Maybe not. If he's really seriously afraid that I'm going to clobber him with this club, right? Beat him to death with the club, he may say, "Whoa, I'm going to get out of here," right? And take off.
That too.
That too, right? He could. So this is an inference, but you know, it may not be a right inference, right? It may be that he's going to take off. He's mad. We've discussed that, right? Maybe he's not mad. Maybe he's happy. Could he be hungry?
Yeah.
He could be hungry, right? He could be looking for a meal. So
Eat Jason.
so we can come up with, what are we going to do?
Eat Jason.
Hey, Jason. Well, they're not that big, all right? Rattlesnakes aren't that big, all right? They don't get that big. I'm not an expert on snakes, but rattlesnakes maybe get 3 or 4 or 5 feet long at the most, right? And most of the time, right, if you walk up on a rattlesnake, right, and you don't tease him or anything, right, he's not going to strike you. Right? Most of the time, he's going to get away. He's going to try to get away because he's looking at you and he says, "Whoa, you know, here I am. I weigh 4 or 5 pounds, and here's this guy that weighs 220 pounds. All right, much bigger than I am, right? So unless you get him cornered or start teasing him and make him angry, then he's going to scoot out and get away, right? Now, if you're a little mouse, right, which is dinner, and he's hungry, then he's going to come after you for sure. So we have any problems with what is an observation and what are inferences? Now, inferences don't always have to be right. The inferences that we make are based on what? Our observation and our knowledge, right? I have a different amount of knowledge than you do, than Jason does, right? So my inferences may be a little different than his inferences. But if we are a bunch of scientists and we're sitting around the conference table and we've collected all of our observations and we make our inferences, we can discuss those inferences and come up with a set of inferences that we all agree upon. Okay, so now then, I have another set of footprints, right? Ancient ones. These are fossilized footprints. They've been in the stone down there for 1 million years. Right? What are the observations on those?
That is green and pink.
Green and pink. Anything else, Jason?
They're going kind of the same direction.
They're sort of going up in the same, towards the same spot. Are they same shape?
No.
They're different shape. This is another observation. Is one bigger than the other one?
And wider.
And wider. Okay. Anything else we can observe?
There's more on this side than on that side.
Okay, more on this side than there are on that side. What about the spacing between them? What about the space from here to here, from here to here? What's going on this one from here to here and from here to here? What happens to the spacing?
It's all different.
It gets a little bit longer as we go from here to here, right? This is the space, right? This is the space here, right, which is much wider, right? What do you think may have happened? Let's do an inference on that. What do you think may have
It could have just started walking.
Right, he could be walking like this, and then if he starts to run, what happens?
It gets bigger.
His foot space gets bigger. So one of the inferences is he's walking along here possibly, and then he started to run. All right, what about this one over here?
Same thing.
Same thing. He was walking along, and then he started to run. All right, you got any other inferences? What do you think happened?
They probably hit each other.
Probably hit each other. Okay.
They might be running from another animal.
Might be running from another animal. They might have seen something and started running. Could they be chasing one another?
How?
Or
they
maybe
gonna
this
chase
one
one?
walked along, he looked over there and saw that one and said, ah, dinner. Right, and he started to run and chase him. Could that have happened?
Mhm.
Do we know? We don't know for sure, but it's an inference. Okay. Let's go to the next step. Now what's going on?
It looks like they was chasing each other,
Looked like they were chasing each other. And what are they doing here?
going around circles
Going around in circles, chasing one another, huh?
or fighting.
Or fighting? Because our observation is that what led you to that inference that you just made?
They was running around in circles. There's a lot of
Because the
footprints like
footprints
that.
are all running around in circles. Jason, do you agree with his observation and inference? So you think that's what happened, huh? You think this one was going along here and maybe he saw that one, right? Decided he was dinner, come up here and they met, right? And then the big one was chasing the little pink one around, right? And trying to get dinner. You think that's what happened?
Could have happened.
Could have. So, the observation in this case is the footprints come along, right, and they go up here and they start going around and around and around in circles in that one spot, right? Our inference is that maybe the big one was chasing the little one and looking for dinner. Is that what we were thinking? They're having some sort of fight. Are you ready? Let's go to the next one.
The green one ate the pink one.
But what's your observation?
That the green
That's
one.
that's an inference. The green one ate the pink one.
You don't see the pink one no more.
You don't see the pink one anymore. That's the observation. All you see is the green footprints going away. You agree with that?
Yeah.
You got maybe another explanation?
The pink one might have gone away.
Pink one might have gone away.
Flew away or something.
He might have flown away. We ask a question. The footprints happened at the same time.
Maybe not.
Maybe not. They could be that they maybe not happened at the same time. There's nothing we can observe here that says that they happened at the same time. I mean, this happened a million years ago. Maybe one day, right, the big green thing come along, right? I'm walking up here, saw something, went over there and went around in circles and then left, right? The next day, the one with the little pink footprints came along, saw the same thing, got all excited, started running up here and running around in circles. But what happened to it? Right? These footprints may not necessarily have happened at the same time. Could have been 2 different days. We don't know. We can't look at this drawing and make that observation that they all happened at the same time. So let's assume that they didn't happen at the same time. Now then what? What do you think might be the story? How can you explain this?
The green one seen the pink one. The pink
Maybe
one
they
started
didn't see
running
each
around.
other at all. Maybe they happened 2 different days. Jason, what do you think?
They're just walking.
They're just walking up here and walk. But why did they start going around in circles if there's that one same spot?
Playing tag.
You're walking down the street, Jason, and you come to a mud puddle. What do?
Go around.
You go around it, right? And when you were littler, what did you do?
Go into it.
You jumped into it and run around, right? So maybe, a million years ago, there was a mud puddle here, all right? And this big green thing come up and says, ah, my feet are hot. And he run around in it, okay? Cooled down a little bit, all right, and walked away. The pink one come along and said, ah, my feet are really hot because they're pink, right? And he go up and he run around in the mud puddle. Then, but then what?
He flew away.
He might have flown away. Or, is there any other possibility?
They could have both been playing in there.
They could have both been playing at the same time too, right? They couldn't have, they don't necessarily, they could be together and not necessarily be fighting or eating one another, right? But what happened where did that pink one, what happened to his little footprints? He could have flown away. Is there any other possibility?
The green one could have gotten hungry and ate it.
Yeah, the green one could have got hungry and ate him. Or
He could
maybe,
have drowned inside the mud puddle.
maybe this is the baby of this one, right? And they both come up there at the same time and they run around in the,
And then the green one carried
and
the
then
pink one.
the green one, the little pink one climbed up on the green one's back and they walked away. That's a good story, right? Well, we're going to come up with a lot of stories here. We don't know the answer for sure. Right, but what happened if it was on different days, going back to our assumption that maybe it was different days, and there was a tree here, right? And this little pink one, right, likes to climb trees. He ran around in this puddle of water, and he climbed up the tree and jumped off into another tree like a monkey from tree to tree. So what have we done? We've made some observations. We got big green footprints, little pink footprints, right? And they're walking along. All of a sudden they start to run. They get up here, right? And we can see that they're running around and around and around in circles, right? Or at least the footprints are going around in circles. And the pink ones go away and the green ones leave. We don't know what happened to the pink ones. We don't see anything. Right? So, and this could have also been, right, instead of a mud puddle, possibly another inference is that maybe there was a big ant hill. You know how ants make a hill like a nest, right? And maybe both of these things like to eat ants, right? And they run up here and they run around chasing the ants. The big green one ate all of his ants and he walked away. The next day, the little pink one came along, right? He happened to be a bird, right? He ran around, ate some ants, and then he flew away. What about our inferences? We have a whole bunch of inferences, right, with this one. We come up with all kinds of things. And the thing is, you notice, if we looked at pieces of it, like we did, first of all, our observation of just the bottom piece, right, we only had just a couple observations. One was we had two sets of footprints, right? One was bigger than the other. They were sort of going in the same direction. They could possibly have started running because the footprints spread out a little bit, right? And that was our observation. With that set of observations, we come up with a set of inferences, right? Which couldn't necessarily be right or wrong. Then we come up and we get a little more information, right? We'll make a few more observations. We still have the green footprints and the pink footprints, but now they seem to be going around and around in circles, right? And we come up with another set of inferences because we have a little more observation, right? And then we come up with the last observation where the green one goes away, walks off. The pink one just sort of vanished. So that gives us some more information, some more observations, and we come up with a different set of inferences based on what we know. All right. Let's do this one now. This is a cover off of the Smithsonian Magazine, which is a museum. What do you see, Jason?
An animal.
I see an animal, right? Right there. What kind of an animal is that, do we think?
A frog.
It's a little frog. What else do we see?
A plant.
A plant. What else do you see? Those are observations, right? We got a frog and we got a plant. Anything else?
Words.
We got words on it. Anything else?
Colors.
We got different colors. Jason, what do you see?
Leaves.
Leaves. All right. Anything else?
The frog is looking up.
The frog is looking up. All right. Anything else? What about the leaves, Jason?
They're on each side.
They're on each
Same
side.
Directions.
Anything else, Julio, about the leaves?
They're green.
They're green. Yeah. Anything else? Now then, we really gotta observe this and look at it. Which direction are the leaves going?
Outward.
They're going out. Are they going straight out? Or are they going up? Or are they going down?
Down.
They're going down a little bit. Right. Anything else you see about that? Look. Anything about the stem on the plant?
It's a different color than the leaves.
It's a little different color in leaves, all right? Anything else about that stem?
It's fuzzy.
It's fuzzy? What do you mean it's fuzzy?
Yeah, if you look real close, you can see it going like that.
Okay, it's a little fuzzy. Anything else?
A little line going through it.
It's got a little line going down. You mean like this? This little line going down here like that?
Yeah.
Okay, that's because of the lighting, right? The way the light is hitting the, right? If you look at that round stem, right, and it's lit, okay, there's going to be a little shadow down through the center. That's a little shadow. It's not that the stem is a different color, but that's a good observation. Right? Any other observations we can make? So far, we've got little animal, frog, which Julio, I think, said was looking up, right? We have some leaves, right? They're green. They're sort of drooping down a little bit. We have a stem with a little line through it, right? Anything else about that stem that you notice? Let's concentrate on the plant for a minute. It's the stem and the leaves. Is there anything you notice about the stem and the leaves? But maybe a little different. I looked at this picture for a long time, for about a month before I decided what was wrong with it. When I looked at it, I immediately said, okay, there's something wrong with this picture. But I couldn't figure out what it was, and I had to look at it. I looked at it for a long time, so don't feel bad. It's, the couple minutes we're looking at it here if you can't come up with all the observations. Let's look at the leaves a minute. What about this leaf compared to that leaf?
It's fat, it's skinnier.
This one down on the bottom is smaller than the one on top? How many plants do you know that do that?
A lot.
Some? All right. Let me ask you a question about the stem. What about the size of the stem down here and the stem up here?
It's skinnier in the bottom and fatter on the top.
How many plants you know do that?
A lot.
Hmm?
A lot.
A lot?
Yeah, because from the root to the top, it gets
Get
fat. and then
if I go out here to a tree, okay, and I look at a tree, and I got a tree with a little skinny trunk down on the bottom, and it gets
it
up
could
the
be
top,
upside down.
and it gets up to the top and it gets bigger. What's going to happen to that tree?
That could be upside down. It'll fall.
Oh, now you're coming up. All right, we made an observation, okay, that it's smaller here than it is up here, and your inference is it could be upside down. Right? That's true. On this picture, on this cover, on this famous magazine from a famous museum, that plant is upside down on the page. Now, the question is, why is it upside down? I have a little more information than you do because I read the article, right? So and the photographer, right, talked about the difficulty he had having all these little, he took pictures of several animals, all right, and little itty bitty animals, and he had trouble making them all stand still long enough for him to take the picture, right? So this is all a set-up shot, right? So what we don't know is we know that on this page, this plant picture is upside down. What we don't know, right? It could be upside down for a couple reasons. But what we don't know is for sure is when the photographer set this shot up, right? Did he take a plant and put it upside down and get the little frog to sit on top of the leaf?
The frog could be upside down, and the plant could be upright.
Right. When he took the picture, the plant could have been around the other way, right? And the frog's got little sticky feet, and he could be sitting on the bottom of the leaf, looking down, right, looking for a bug or an insect, right? But then when the editor got ready to set up the front cover, he says, "Oh, that frog looks sort of stupid upside down. We're going to flip the picture around," right? And they could have printed the picture backwards, or flipped, not backwards, but flipped. So we look at this, and we made some observations. We could have made a lot more observations. There's a black background. We could have said, oh, well, maybe it's dark outside or something, but actually that's black velvet behind there. And because, like I said, I have more information than you do because I read the article, and I know these are all set up. But our other observation was these green leaves are sort of drooping down. Right? There's a frog attached to one of them. The stem is smaller here than what it is here, and that's what led us to the inference, Julio, that the plant was upside down. And that's a pretty good inference because we know that plants don't grow with the stem small at the bottom and big at the top, because if they did that, they would fall over every time. Right? After they got up so tall, this heavy part up here, right, and this little piece down here wouldn't have enough strength to support it, and it would just fall down. So, observations and inferences, again, all scientists and engineers, right, have a very well-developed skill of making observations and making inferences. It's key to their work, right? You have to be able to observe things, collect the data through their senses. Maybe it's not just their senses, but the senses and my observation is that you're sleepy. Or you're yawning, and the inference is that you're sleepy, right? So they have to use some test instruments to make the observation because, like I mentioned before, when the X-rays coming in from outer space, of course we can't see X-rays, right? We can't see radio waves and so forth, so we have to have some sort of an instrument, right, that gives us some visual indication that we can look at or hear, right? And we use all of our senses. Normally, though, in our lab experiments that we do in school, we don't do what? We don't taste, right? We don't smell things, right? Because you don't know what you're tasting, all right? And it could be hazardous to your health and also the smelling thing. Usually we don't touch things either, right? Because, it could be hazardous materials that we're working with, right? So observation is the act of collecting all the real data, right? Things that we know for real. Right? And then the inference is an attempt to explain what has happened, right? What caused those observations. All right, you can do these experiments or observations and inferences at home, right? By taking magazines, looking at them, right? Taking a look at the pictures in the magazine, reading articles, whatever, and making some observations, and then you come up with a story. Everybody does this all the time, right? You're walking down the street, right? I'm an old guy, I'm going down the street, right, and I see Julio coming along with his baggy pants, his curly hair, and his hoodie on, and I'm saying, Julio's a bad guy. All right, I'm not going to have anything to do with him. But I know Julio is being really a good guy, is almost as good as Jason, right? but that's an observation, right? I make an observation, I'm looking at you, right? And I come up with an inference. It could be right or it could be wrong, right? But it's all based on the observations that I have. All right, that's it for the next time. All right, I hope you go home and try some of these observations and inferences, and we'll see you next time.